Welcome to the Virtual Reality Chemistry Lab. This is a chemistry lab that was built for students in high school wishing to take AP Advanced Placement Chemistry online, which is currently not offered by a majority of online programs due to the lack of immersive labs. So what I've built is a fully immersive high school chemistry lab that students can take their labs online. This is important because students receive college credit for AP courses. So as you can see in the back here, we've got a stove, a sink, a fully loaded storage area with over 20 different types of chemistry equipment. And we've got 2 different experiments we can try today. Let's go ahead and get started with the first, nitrogen triiodide. So the first thing the students will do is watch a video introducing the experiment.
What we have here is a contact explosive called nitrogen triiodide. It's a highly unstable substance that detonates when disturbed. Now you might have heard of nitroglycerin, which is another kind of contact explosive, which goes off when you hit it with a hammer, but this stuff is in a league of its own. Even something like a mosquito landing on it will set it off. Now the reason this compound is so unstable is all down to how it's put together. Now it's nitrogen triiodide, so we have a nitrogen atom, and this is a trivalent atom. That means it likes to form 3 bonds with other atoms. So when we bring it together with iodine, it forms bonds with 3 iodine molecules, and they all go on this side of the nitrogen atom because of the way that the nitrogen's electrons are arranged. So, the iodines all go on over here, and you can kind of see there's a bit of a problem here, which is that there's not a lot of room for all these iodine atoms. They're much bigger than the nitrogen atom, and so they're all kind of squeezed together and all repelling each other. And this creates something called bond strain or steric strain, which makes the whole molecule less stable than you'd expect it to be given the components. Now chemists would say that this results in a low activation energy for the decomposition of this molecule. Everyone else would probably say that it's liable to fall apart.
Let's go ahead and get started with the experiment. So if we head over to the table here, we'll see that all the instructions are listed here, but the current instruction is listed right in front of us. So the first thing we need to do is gather the following materials: ammonia, iodine, beaker, tub, scale, and a feather. So I'm going to grab this beaker here, go ahead and grab this tub, and we can set these down right there. We're going to need iodine and just a little bit of ammonia. Set those down there. And the last 2 things are a scale and a feather. So the first step is to add enough ammonia to cover the bottom of the beaker. Let's grab our ammonia. Go ahead and pour this in here. Measure out 1 gram of iodine on the scale and add it to the ammonia in the beaker. This is actually a fully functional digital scale here, and all of these ingredients are pre-tiered, but we'll go ahead and just demonstrate the scale. So let's measure out 1 gram of iodine into the beaker now. Pour the solution into the tub. So here we have Ni3. Let's go ahead and get it into the tub so it can dry. Let it dry for a second, and then we're just going to touch a feather to the dry Ni3. I'll move the beaker out of the way here. So now we want to stand back, because as we saw in the video, this is a pretty violent reaction. Wow. Congratulations, you've successfully completed the first experiment. Let's go ahead and start with the second experiment. Sucrose and potassium chlorate. Let's go ahead and watch the introduction video.
What is it that we love so much about gummy bears, and really any candy? It's the sugar that's inside, the sucrose. Now, the sucrose is what provides us energy. Okay, that's what gives us calories. Each gummy bear here has about 7 calories in it. So I'm going to heat up something called potassium chlorate. And this is going to break the sugar down, just like what happens inside our body when we eat a gummy bear. It breaks the sugar down and releases the energy. Only This chemical is going to allow it to happen a little more quickly than it happens in your body. What? Oh my gosh. It smells like burnt marshmallows. You see all that energy come off of there? That's calories. Oh man. Yeah. Calories always get a bad rap, but calories aren't a bad thing. They're just a measurement of energy, especially when we talk about foods, how much energy is in that food. Now, to get the energy out of this gummy bear, I needed to use the sodium chlorate. You can see the reaction for the decomposition. That means it's going to break apart into sodium chloride and oxygen gas, and actually a few other things as well. As it breaks apart and releases the oxygen, now that sugar, that sucrose that's inside that gummy bear, can start to react with the oxygen and make fire. And that's what we see, all of the energy coming straight out of our...
Let's go ahead and start this experiment. So we need to gather the following materials: potassium chlorate, sucrose, test tube stand, scale, and a blowtorch. So let's grab this stand here and this test tube. Potassium chlorate and sucrose. Grab the blowtorch and the scale. Alright, step 1. Attach the test tube to the test tube stand. Let's turn that around there. We'll attach the test tube here. Step 2. Measure out 5 grams of potassium chloride on the scale and add it to the test tube. So, this is only 2 grams, so let's head back and grab the 5 grams. Let's double check here. Yep, 5 grams. And we'll add it to the test tube. Step 3 is to melt the potassium chlorate with the blowtorch. Get this nice and melted here. And now we're going to add a pinch of sucrose. Before I do that, I'm going to grab this fire extinguisher. Anytime we're dealing with fire, these are good to have on hand. Alright, let's carefully add this sucrose. I'm going to stand back. Here we go. Congratulations, you have completed the experiment. So that's all for the virtual reality chemistry lab.